From Utah Public Radio, this is UnDisciplined. I'm Matthew LaPlante. A lot of people are rightfully concerned about how agriculture is going to be affected by climate change. A warming globe means more moisture in the atmosphere, and so some areas will experience more rainfall and harder rain events, which can flood croplands and wash away soil nutrients and make it impossible to get harvesting tools into the fields. That's already happening in areas like southern Indiana, where extreme changes in annual rainfall have been complicating corn and soy production. Climate change also means more heat, and many areas will experience warming temperatures, which can dry out farmlands and render soil incompatible with many crops. And that's what's been happening over the past few decades in much of the American West, and especially Arizona, which impacts the production of fruits and vegetables, grains and honey, and leaves many lands insufficient to sustain ranching as well. We tend to look at these problems generationally. That is to say, that we think about what our grandparents and perhaps even their grandparents were able to grow on a piece of land. And we observe that we either won't be able to grow these same crops or we already can't under the changes brought on by climate change. That's an understandable concern. But even when we think about our grandparents, that's 5 generational field of conception, we're only looking at a very small slice of the history of agriculture. There is evidence that humans have been farming for about 20,000 years, and the first agricultural revolution, the major transition from hunting and gathering to settled agriculture across most of the world, happened 10,000 years ago. And there have been major shifts in climate during those years. In the vast majority of those cases, those shifts haven't happened as quickly as what we're experiencing as a result of increased greenhouse gases in the atmosphere. But humans have chased favorable growing climates and suffered under unfavorable ones for up to 1,000 generations. This idea is put into perspective in a new paper about how corn cultivation moved across the Southwest as long-term climate regimes took hold and shifted over time. The paper was authored by Timothy Kohler and Andrew Gilreath Brown. And if you're a longtime listener of this program, you might recognize that latter name. Andrew first joined us in 2019 when he was a doctoral candidate at Washington State University to talk about the discovery of a 2,000-year-old tattooing needle. He's now a data scientist at the Yale Program on Climate Change Communication. Andrew Gilreath Brown, welcome back.
Thanks for having me back. It's good to be back here.
Andrew, let's do a little connecting of the dots here, because the last time we chatted, it was to talk about ancient tattooing tools. And I think at the time I tried to goad you into getting a tat with one of these things. Did that ever happen?
No, I still haven't yet, but it's still on the it's on the to-do list. But I do still have my whole sleeve though.
Tell me about your sleeve. What's on your sleeve?
So I call it my archaeological CV, my resume, and so I've done research or excavations on a variety of different places, like on turtle shell rattles, ancient music in North America. One time I did an excavation in Tennessee, digging up mastodon bones, some of the earliest there in Tennessee. Even found a giant sloth tooth, so that was pretty cool. And then I have some trees and water that kind of signify how a box turtle goes in between different worlds, in between both land and water.
Let's jump into this CV a little bit. You got super into the ancient history of turtle shell rattles for a while. Tell me about that.
Yeah, so when I was at Middle Tennessee State University, I had an opportunity. I'd always been interested in music and was actually doing a minor in music there as well. And so I got a chance to look at it, look at archaeological data, and jumped into it. I like did some experimental stuff. I recreated some rattles, tried to identify them in the archaeological record, and tried to really understand the depth and age and ancient components of how long indigenous people in North America had been using turtles.
And that's reflected on the sleeve somewhere. There's like a turtle shell or a turtle shell
Yeah,
rattle.
a turtle shell. Yeah.
Okay, now about the same time, you were thinking a lot about how to better estimate what ancient climates might have looked like what soil moisture might have been thousands of years ago. That's part of your CV as well.
Yeah, so essentially I wanted to try to understand more on an individual level, when people in the past looked out at the landscape and were trying to figure out where to farm, what did they see? And so I kind of used that through using soil moisture, which is just the amount of water content that gets retained in the soil. And so I did this doing kind of a geospatial analysis and of using lots of different like national soils data and some other calculations to try to understand essentially where on the landscape would have the best soil moisture for farming locations.
Then you've also done some work on like dystopian worlds in sci-fi?
Yeah, I did a it's called the Complex System Summer School through the Santa Fe Institute, and we, kind of get the opportunity to kind of organically come up with whatever projects we wanted to as part of that summer school. And yeah, so me and a couple of other people came up with this idea to try to simulate different sci-fi worlds. So we came up with doing 1984, and I did Fahrenheit 451.
And have you tatted that part?
No, that part's not on there. I gotta get on that. I guess all this needs to be part of my second sleeve.
No, which arm is it that you have sleeved up so far?
The left. So
Okay,
I've
all
got the
right. So
whole right.
you got space to work with for all of this.
Yeah, I got a big empty arm canvas.
Okay, no, I want to stop here for a minute and say like this is not a normal sort of research trajectory, like at all, right?
No, not really. No. So
So let's dive into that just a little bit. Like, why does your brain work this way? Do you think where you're like just jumping around on all of these different, really fascinating, by the way, things?
I think I just like generally have an interest in so many different parts of the past and trying to use things like modeling and simulation to try to understand what the past was like, kind of understand these systems, like is there a point that we could like stop a trajectory like that happening? So trying to understand civilizations or cultures having trouble going through hardship, or are there other things that they could have done, that they did do to buffer against, things like, shifting climates and major droughts, the resiliency aspect?
It can be hard for any scholar to market themselves early in their careers. It can be particularly hard for someone I think like you because like academia is so very used to people who have a lot of expertise in one very specific, very like hyper specific thing. We talk on the show about like subfields of subfields. And then here comes Andrew, and he's like, "Hey, I helped rewrite the history of tattooing, and I helped show what temperatures might have looked like thousands of years ago. And hey, I gave people different ways to think about science fiction, and and you did have you had a little bit of a rough job search there for a while. Were you feeling frustrated?
Yeah, definitely. I was, yeah, definitely feeling a little bit down, and I did have a couple of like good opportunities that did pop up, but it was just hard to work out logistics with that, especially when you have a family.
Yeah. We've already kind of spoiled this part of the story, but you are at Yale now. That is fairly new. That's also not a bad place to land. What will you be doing at Yale?
Yeah, so I work for the Yale program on climate change communication, and I'm a data scientist there, primarily doing different types of models. Some of our like major products are what we call the Yale climate opinion maps, and so trying to understand where people stand on different components of climate change. So trying to really understand where people are right now in terms of beliefs and attitudes. And one of the things that I also started working on is trying to understand these different components like heat and agriculture, trying to understand how worried people are about some of those different things like drought and flood.
And so this gives us a good opportunity to kind of get back to this question about agriculture and ancient climates. To do that, let's talk briefly about this 5,000-year-old estimation of temperatures for the US Southwest that you started working on several years ago at Washington State University. Because this really was the enabling tool for the maze study that we're going to be talking about today. And maybe as a little bit of background here, we have observational temperature records for a few hundred years. I think most people realize that. I think most people also understand that within a reasonable degree of certainty, we can derive precipitation records going back thousands of years using tree rings in much of the world. But how do we reconstruct temperature records going back thousands of years? That's harder.
Yeah, especially so like within the southwestern US, we can really only get tree rings about 2000 years ago. So really anything beyond that we don't have and can't really reconstruct at least from tree rings. There are other means like stable isotopes and things like that that you can get from caverns and caves and things like that. But a lot of people have turned to pollen to reconstruct for much longer periods of time.
And how do you do that? How do you use pollen to do those reconstructions?
Yeah, so essentially, as you said, we have climate data, weather data that has been, recorded from weather stations that is still ongoing, and so we have, kind of across the U.S. For example, we have all these weather stations that have been collecting temperature, precipitation data for decades, and there have been palynologists, people who study pollen, that have collected pollen samples just on the surface, also around the US. So that gives you a sense of here is a group of pollen, which represents, different vegetation constructions. So you have, maple trees or your oak trees, whatever, and different types of plants and grasses that represent a particular location. And that kind of goes along with that temperature signal that you have recorded there. So generally as weather changes over the long term, so if things get hotter, the vegetation that makes up that space is going to also change, but that does take time. It's not an overnight process.
Yeah. And then when we go back and we look at old pollen samples, and scientists will do this by like taking a core sample of like a bog, right? Like you drill down and you pull out these pollens from, many, many centuries, even many thousands of years ago. And you can see these layers of the pollens and you can analyze how they responded during these more wet times, more dry times, more hot times, more cool times, correct?
Yeah, absolutely. So they go through and they identify kind of the pollen in each layer, and then we use things like charcoal that's been kind of naturally deposited to assign dates throughout that core, so that you know what time period that the core and those pollen samples date to, and then you can get a sense of how vegetation has changed throughout time. And so what we do is we use this technique called the modern analog technique, essentially to match within that old pollen layer. You can match it to somewhere else, say in the U.S. that has a similar composition, and then using that, you can get that temperature data from that location. So we use that, and you do that many times over from the same core, and then all the cores within your study area.
And using these reconstructions of temperature and precipitation, it became clear to you that there were long periods of time in which the climate of the Southwest, the United States Southwest, was cooler and wetter. And these days, we generally associate that with El Nino. And there were these like long periods of time in which the climate in this area, the Southwest, were warmer and drier. These days, we would generally associate that kind of climate with La Nina. I do want to note here that El Nino and La Nina are oceanic and atmospheric phases that shift every few years. And this reconstruction wasn't intended to identify specific phase shifts, but these are sort of easy ways to sort of visualize or think about what kind of long term climate regimes were at play for much longer periods of time in this record. Do I have that right?
Absolutely. Yeah. So we weren't trying to. So this was a low frequency reconstruction, so we're talking over at least decades, if not centuries. And so, what are the dominant patterns within that time? Of course, El Nino and La Nina alternate ever so often, every few years. So we're just trying to capture the longer term patterns.
And as you sat with this time series, as you are watching these slow ebbs and flows of temperature across thousands of years in the data, the more El Nino like periods and then the more La Nina like periods, you began thinking about what these shifts would have meant for the people who lived in this part of the world, because that is how your brain works. A- And pretty quickly, I assume you began wondering about maize, corn, which was the key crop for people in these areas going back for thousands of years.
That interest really started during my master's, again with the soil moisture stuff, of really trying to critically think more about, on a local level, how are people responding and to their landscape and the environment, and how are they looking at it. And so a big part of that within the Southwest and is trying to understand the spread and domestication of corn agriculture, of maize.
Maize farming began in southwest Mexico many thousands of years ago. This is way down in the tropics. And now, of course, you can find corn farms all the way up in Canada. There's even some efforts to grow corn for animal feed in Alaska. So you can imagine this agricultural frontier moving slowly northward over time. And one of the things I really enjoyed in the study was that you and Tim tracked this frontier over thousands of years. And from that, you could derive a rate of expansion.
So yeah, we tried to record as bring together as much of the maize macrofossil, and by macrofossil I just mean the actual corn cobs themselves. There are lots of other things that have been recorded for corn, like starch grains that were recorded even earlier than the Helenicetes corn. Back to 6800 BC, but also down in the kind of central Bosphorus region.
How did the movement of that frontier, which you're tracking archaeologically through these cobs and this other evidence, how did the movement of the frontier change when prevailing climates were El Nino like versus when they were La Nina like?
Well, I think what we see really is that it was probably likely that they were brought into new areas as probably more experimental, or just trying to use some things that have been used in other places before we really see, large population explosions of high growth rates in the population. That happens much later than kind of the first evidences of maize. That happens at a place called Las Capas, where you have pretty higher growing degree days than you do, say, once you get up into Utah and Colorado. But there's still about 2,000 years before you really see population explosions there, from when the first time corn shows up there.
So you see it initially like somebody's like, hey, let me try this out. And then over time, you see populations begin to adopt it, but the climate's got to cooperate, right?
So part of it is that where corn was initially domesticated in the central Bosphorus, you had growing degree days of about 5,000. And growing degrees days are just like this heat accumulation, heat energy record that people use to kind of understand the growing season. You need a certain amount of them for corn to grow successfully, and for those to happen at different points of the growth cycle for corn. And so going from something that's adapted to grow into 5,000 degree days to like 500 is a very different atmosphere and environment. And so we know that you had to have time for corn to adapt to these different kind of climate regimes.
And so, what we're seeing across this long, expansive time is not just people moving corn into areas where the climate at that particular time was cooperating, but also we're seeing the genetic development of corn over time as well to a crop that's more suitable for regions and regimes that might not have been so favorably at one time. So there's quite a few axes here, yeah?
Yeah, absolutely. It's a very complex topic. It's not also it's not a direct route. So this is not a direct route from central Boston right into the Southwest. You have to think about lowland versus highland routes. We actually think that there might have been individual ones developed along different elevation gradients that eventually came into the Southwest. And so, yeah, there's a lot going on.
How does all of this impact the way you think about the ways in which we need to adapt to climate change today? Because you've looked at this in sort of the long, I mean, we're talking about thousands and thousands of years of history here in this movement of corn south to north from, more suitable regimes to less suitable regimes to, those less suitable regimes becoming more suitable either because of climate change or because of genetic change in the way that we cultivate the corn, but we managed, right? Like somehow this little tiny grain, and ancient corn grains look really nothing like what we think about when we think about maize today. We made it. We somehow over these thousands of years figured out how to adapt this really important food product to a much broader area of the world. So again, back to my, this is kind of a long way to ask this short question, but how does this impact the way you think about our adaptation needs and potential right now?
I think it speaks to the human creativity and intuition. So the indigenous people of the Southwest, the ancestral Pueblo people, were wildly successful at developing these different land races that were well suited to different types of environment. And we know that particular varieties were more drought resistant, even in some cases more drought resistant than some of the varieties that we have today. And so relying on that environmental and local knowledge from indigenous people, I think, is wildly important in hearing their voices.
Andrew, a lot of us, when we think about the past, we think about, our grandparents, our great grandparents, maybe, if we go way back, we might think about the founding of our nation that happened, a long, long time ago. Um, but doing work like the kind of work that you do requires you to think in spans of hundreds of generations, to a time before Christ, before the Roman Empire, before Mohammed. How does thinking in these ways about the world impact the way in which you think about the immediate challenges that we face today?
We can only look at like kind of an average of usually several generations of what we're seeing. And yeah, you're right. I think about my grandparents, and on their land they used to farm cotton and corn on 24 acres of land. That's a lot of crops. And but thinking even deeper in the past and over thinking over longer periods of time, we really think about the resiliency of some different cultures at different times and how people responded to uh, different climatic downturns. In some cases, they may have, in periods where farming in a lowland environment is, maybe not good. In some cases, would move fields to, higher places that might be particularly good in a different time. Or when the ancestral Pueblo people of southwestern Colorado decided to leave at the end of the 1200s, they went over to the Pajarito Plateau, or a lot of them did, which was able to kind of handle some of those droughts better than southwestern Colorado.
That's Andrew Gilreath Brown. He's the co author of a new study on how ancient maize farmers in the U.S. Southwest were impacted under long term climate regimes That study was published in Kiva, the Journal of Southwestern Anthropology and History. Andrew Gilreath Brown, thank you.
Thank you.
Undisciplined is a production of Utah Public Radio, and if you happen to live in Utah, you can listen to us on UPR every Thursday morning at 10:30. If you miss us, then you can listen to every episode of Undisciplined wherever you get your podcasts. Our program is supported by the College of Humanities and Social Sciences at Utah State University, and from listeners like you. You can support our work at donate.nprstations.org/UPR. Our producer is Reagan Edelman. Our theme music is Little Idea by Benjamin Tissot, and I'm Matthew LaPlante. Thanks for listening. Now go have big ideas.